So within functions in algebra, there's something called direct variation. And direct variation, and we can write it right here, direct variation. Direct variation is written in the form of y equals k times x, kx. So y equals kx. This is direct variation. So a direct variation is a linear function of this form, y equals kx, where k is not equal to 0. So we have k not equal to 0. Okay, and k actually stands for constant. And yes, obviously constant starts with a C, but we still use k to stand for constant because the constant of variation for a direct variation, the constant of variation for a direct variation is the coefficient of x, and k is the coefficient of x here. So here we're going to draw a little bit of a line right here, and this is the constant of variation. Constant of variation. All right, so let's see how are we able to identify whether direct variation exists or not. So if we were to imagine an input and output table, and our input is our x and our output is our y, as always, and y is dependent on x, so y is always going to be exactly k times x. So whatever x happens to be, x is our independent variable, whatever x happens to be, y is going to be k times that number. So let's look at a table here, and let's see if we can identify direct variation. So if I were to, let me just change colors here, and just make a x and y, and then we'll make a little table. Okay, so let's give an x value of 1, 3, and 4. And then we'll give a y value of 2, 6, and 8. All right, now we're asked, for this function, for this table of values, does y vary directly with x? So does y vary directly with x? So is there direct variation? Well, let's look at it. So if we're going from 1 to 2, well, that's going to be times 2. If we're going from 3 to 6, that's times 2. If we're going from 4 to 8, that's times 2. They're all multiplying by 2, so I can already tell that y does vary directly with x. There is direct variation. But if we were to, if it was a little bit more complicated than this, the easiest way to determine direct variation, or we can actually figure out the constant of variation by dividing y over x. So y divided by x, or 2 over 1, or 6 over 3, or 8 over 4. These are all equal to 2, which is our constant of variation, which will give us our function rule, which is y equals 2x. Okay. So I'm just going to block out just going to get rid of this here for a moment. Sorry about this. Okay. So say we're given a different table and we're asked the same question. Let's imagine the table x, y, and we have 1, 2, and 3, and then these correspond to values of 4, 8, and 11. Now we're asked the same question: does y vary directly with x? All right, well, let's see. Let's try to figure out the constant variation. Y over x is equal to, in the first ordered pair, we have 4 over 1. And then the second ordered pair, we have 8 over 2. Well, those are actually equal. 8 over 2 and 4 over 1 are equal. And then on the last ordered pair, we're given 11 over 3. Now that is not equal. That is not equal. So y over x is not a constant, and y does not vary directly with x in this scenario. Now the other way that we could be given this is if we were given an equation. So if we were asked, let's say 7y equals 14x plus 7. Well, if we're given this equation and then we're asked if y varies directly with x, the same question that we were just trying to figure out earlier. Well, first what we need to do is we need to actually solve for y. We need to isolate y so that we actually have a function, an explanation of a function. Well, if I were to do that, I would have to divide both sides of the equation by 7. Everything divided by 7. And then that would give me y equals 2x plus 1. 7 over 7 is 1. So y equals 2x plus 1. Well, is this of the form y equals kx? No, it is not. Y equals kx would just be y equals 2x. The plus 1 is extra. That would be like adding a constant here. So this equation is actually not of the form y equals kx. So y, we already know y does not vary directly with x. All right, just going to move down here. All right, so say we're actually asked the same question, but instead of being given a table of values, we're going to be given a graph. Okay, so let's look at the function y equals 3/4 x. Y equals 3/4 x. Is this of the form y equals kx? Yes, it is. Y equals kx, y equals 3/4 x. Our constant of variation is 3/4. So we can already determine right here that this actually, y does vary directly with x. But let's just draw the graph so that we get a sense of what a direct variation equation or function looks like. All right, so I'm just going to make a couple of quick axes here. So we have our y-axis and our x-axis. And just going to make a quick table of values just to get a sense of what our graph is going to look like. I'm going to pick some x values that are multiples of our denominator 4, to make it really easy, so that I know if I pick x values that are multiples of 4, that it's going to cancel out with the 4 in the denominator of the 3/4. And then it's going to leave something really simple for me to graph. So if I pick values like 4, 8, and 12, these are going to simplify fairly easy. 4 corresponds to 3, 8 corresponds to 6, and 12 corresponds to 9. All right, so let's make some points here. Let's see, 4 corresponds to 3. And then we get 8 corresponds to 6. And then 12 corresponds to 9. Okay. So we can draw a line through these. Obviously my points aren't perfect, so it's not going to be a great line through these points, but they do, let's imagine that they do go through these points. And I'll kind of extend these points a little bit to make it look right. All right. So we have a line now. We have our function that where y varies directly with x. And here we are. We made a table of values. We made the points. We drew the function, and this is what it looks like. So you can imagine that since there's no y-intercept when y varies directly with x, that the function is always going to cross the origin. Right here, we have the function crossing the origin as we see it right here. And then we're going to have some line, some linear function where y is always the exact multiple of x with the constant of variation. Okay. So that's as far as we're going to go with direct variation.